In this lesson, we will talk about parallel and perpendicular lines. So parallel lines are lines that will never intersect. So when they don't intersect, we know that their two slopes will be equal to each other because it makes sense that they would rise and run at the same rate in order for them never to cross. So we're going to keep that in mind as we're looking at equations of parallel lines, that their slopes need to be equal. Perpendicular lines, however, their slopes are not equal. So notice here a perpendicular line is where it's going to make a 90-degree angle. And to make a 90-degree angle, the slopes must be opposite reciprocals, which means whatever my first slope is, I need to flip it upside down and change the sign. Flip it upside down, change the sign. So opposite, that's changing the sign. Reciprocal, meaning we're going to flip it upside down. The first thing that we want to do is we want to examine equations to determine if the lines are parallel, perpendicular, or neither. So I think the easiest way to do that is to find the slopes of each of the equations, and I can do that by finding the slope-intercept form of each equation. There's more than one way to do it. Some people say plug in a couple of points, find the slope of those 2 points. I think that's kind of silly. So I'm going to take this equation and I'm going to turn it into slope-intercept form. Remember, slope-intercept is y equals mx plus b. So what I'm going to be looking for is that m value once I get it into that particular form. So I'll subtract the 6x from each side, which gives me 2y equals negative 6x plus 9. And then I'll divide it all by 2. So every single thing divided by 2, which gives me y equals negative 3x plus 9 halves. Now, I don't care about the 9 halves at all. I care that the first line has a slope of negative 3. Now I'm going to look at my next equation. I'm going to do the exact same process. I'm going to move whatever the other values are to the opposite side so that I can end up with y all by itself. In this case, I'll have to divide everything by negative 1, and that gives me y equals negative 3x minus 3. Again, I don't care about the minus 3, I just care that it's different than 9 halves. I care about the slope. So now what I'm doing is I'm looking at the slopes. Notice that the slope of the two lines are equal to each other. That tells me that the lines are parallel. They're equal slopes, different y-intercepts, so they are parallel. Let's do another. Same idea. We're going to go slope-intercept form. I'm going to subtract x from each side. I'm going to divide everything by 3. So I get a slope of negative 1/3 for my first line. For my next line, I'll add 3x to each side. And now it's already in the correct form and my slope is 3. So now I'm looking at negative 1/3 and 3. Those are not equal, so they are not parallel. Are they perpendicular? Perpendicular means that I would take my first slope, I would flip it upside down, and I would change the sign. So if I took negative 1/3 and flipped it upside down, that would be negative 3 over 1. Changing the sign would make it positive 3 over 1, which is exactly what I have here. So because these are opposite reciprocals, the slopes are perpendicular, or the lines are perpendicular. Let's take a look at actually writing equations of lines that are parallel or perpendicular. So when we do that, again, we're going to care not about the y-intercept, but about the slope. So notice I've given you a parallel and a perpendicular to the same line going through the same point so that you can see the difference between the two. Either way, the first thing I'm going to start with is this equation, and I'm going to turn it into slope-intercept form. So my slope-intercept form is y equals negative 4x minus 8. Now the reason I need to do that is because what I'm going to do here is use point slope form and then slope-intercept form to write my equation using a slope of negative 4 because parallel lines have the same slope. So I don't really care about this negative 8. I care about that the slope is negative 4, so my new equation that's parallel to that will also have a slope of negative 4. So I'm going to say y minus negative 3, so y plus 3, equals my slope, x minus my x value. Distribute, subtract the 3, and there's my equation. So if I graphed these two lines, they would be parallel to each other, and this line that I just wrote the equation for would go through the point 2, negative 3. Now I'm going to do the same thing down here, but I want the line that is perpendicular. So instead of using the slope of negative 4, I have to find the opposite reciprocal of negative 4. So I'm going to flip it upside down to make it negative 1/4, then change the sign to make it positive 1/4. So now I'm going to say y minus negative 3 equals my slope of positive 1/4, and then x minus my x value. Now this one's going to get a little bit ugly. That's okay. So y plus 3 equals 1/4 x, and then 1/4 times minus 2 is negative 1/2, because I would get negative 2 over 4, which reduces. And now subtract 3 from each side to get y equals 1/4 x minus, it's essentially 3.5. I'm going to turn that into 7/2. So how did I turn it into 7/2? I said, well, negative 3 is the same as negative 6 over 2, and I've already got a negative 1 over 2, so now I've got a negative 7 over 2. So that's what I did. Now you can always check these by graphing. So not a bad idea to plug them into your calculator or into Desmos.com. Desmos is a free download for any of your devices. So I'm going to go ahead and do that so that we can see the original line, the line that is parallel, and the line that is perpendicular. So I wanted to show you on my iPad exactly what to do in Desmos. So as you can see, I've already entered all of my graphs, but I've only graphed the first one. So my original equation was y equals negative 4x minus 8. And notice my second equation, the blue one, when I graph that, see how they are in fact parallel lines. My third equation, which is the last equation I came up with, when I graph that, it should be perpendicular to both of those lines. And as we can see, that does appear to be perpendicular. So that's an easy way to check, is to go into Desmos and enter your equations, and you can see that you did it correctly. So let's try another one of those questions. Again, my first step is to find out from the existing line what is the slope of the existing line. So I'm going to add the 3x to each side, and then I'm going to divide everything by 6, and that gives me 1/2 x minus 2. So again, I don't care about the minus 2. I care that the existing line has a slope of 1/2, which means the parallel line will also have a slope of 1/2. So y minus my y value equals my slope of 1/2 that I've stolen from the other equation, and then x minus my x value. On the left side, y minus 0 is just y. On the right side, I'll distribute to get 1/2 x minus 4, and that's my solution. To be perpendicular, I would take 1/2, flip it upside down, and change the sign. So my new slope will be negative 2. So now y minus my y value equals my slope, x minus my x value. The left side, because it's 0, just turns into y. The right side is negative 2x plus 16. I'll let you do that graphing check on your own. For the last one, go ahead and find the two equations and then press play to check your work. So again, here I have my original equation, which I'm going to subtract 4x from each side, which means the slope is negative 4. So for the parallel line, I'm using the slope of negative 4. So y minus negative 1, so y plus 1, equals my slope of negative 4, and then x minus negative 4, so x plus 4. This side stays the same. On the right side, I distribute. And then I'm going to subtract 1 from both sides to get y equals negative 4x minus 17. For my perpendicular, I'm going to take negative 4, flip it upside down, and change the sign. So my slope will be positive 1/4. So same idea, y minus my y value equals my slope, x minus my x value. When I subtracted the negatives, that made them plus. I'll distribute the 1/4, and then I'll subtract 1 from both sides. And then I don't have to write plus 0, so that's my final answer.